YouTube. Just oh, there it goes. Okay. All right. So, um, a little tired. Yeah, yesterday I got culling sort of working. We got these bounding boxes being drawn, but like these should be green if it's getting drawn. And so, like, I am drawing the correct bounding box because this is like the right size for this thing. It's just the color is wrong, so I'm getting the wrong, the wrong visible instance count or whatever. Hmm. Hmm. And yeah, and like some it's just kind of scattered around everywhere. And then I look at like one, and they all turn green. Hmm. Yeah, so something's not quite right with how this is supposed to work. Um, yeah. But I was thinking there's one thing I want to change first to make some of this a little easier. Um, I don't know, I feel like I need to sneeze, but I can't. Oh. Anyway, so at some point I wrote this. Is it in here? Yeah, it's this little pointer writer thing. You just hand it a pointer, and then you can just keep giving it some data to write, and it'll keep incrementing the pointer by that data, which kind of works, but it's very unsafe. And so, like specifically, um, specifically for doing push constants, and so if I were to like comment out this or something, or set everything to be visible, and I'm not doing testing anymore, well then I have to like disable shader optimizations to get because otherwise, if I don't disable shader optimizations, then like this function will get optimized out, which will optimize out the push constants, which will cause uh, which will cause a seg fault with this pointer writer thing because it assumes a fixed size. So instead, I want to do push constants. I want to have another map variable in that for specifically um, the data. So then let me start here because that'll make this simpler because then I can just like set everything to true and I set everything to visible. Then I don't have to worry uh, about like seg faults or anything with that. So, right, does not return a value in all control paths. This should throw runtime error. So, can I just what does this do? Yeah, it doesn't like that. Really, this is just like a compiler problem. Because it should be able to see that this is a runtime error, and so this will crash. And usually it can see it, but not here. Okay, format, whatever. So I should probably file a bug report with Clang for this. Yeah, I'll do that later. Anyway, me. Yeah. So where are the push constants? All right, so it's right here. So push constant's name is this, and yeah, so I'm just getting the full size. So I need to iterate over each of the push constants, not just that. So comp.get declared struct size. Can I get the members? I know there's something in here for like getting the members. push constant buffers. Let's see. There's something in here for like, here's like array types. It's not it. Here we go. Struct member reflection. I think this is what I want. Yeah, get type. So type. Member types. So let's see. See if I can just print all the names out of these. So type dot member types for const be cross type reference. Member type in member types. Does that work? What do you mean? Viable conversion from typed ID. Alright, whatever. And this is just going to be auto. Member type. How does this work? Get size. Type struct member offset. Get size. Get stride. Here we go. Name. Get member name. Or that's comp.get member name? Yeah. Type.self. What? I guess that's this up here. Or, yeah. That's that type up here. And this is I? Okay. Oh, hey, you're here. Yep. So currently what I'm doing, I'm changing how I want to set push constants. So currently I have this like pointer writer thing, and this is like the easiest thing to segfault with ever. So how I'm handling push constants is I just get the size of the push constant buffer from the shader, like here, and then that this pointer writer thing. What it will do is I hand it a pointer, and then I tell it to write some data, and then it'll write the data and then increment the pointer, so I can like keep calling it again and again, and it kind of works, except for the problem that if I don't use a push constant in a shader, then it'll get optimized out. And then when I try to read the, so then like, so for example, if I were to set visible to be always true, then this PN test won't run, and so I won't need this frustum. And so this will get optimized out from the push constant. But then the that pointer writer thing will segfault, or at least it should, because it's no longer going to allocate space for the frust constant. So you have a class for pointer plus plus equals value. Yeah, basically. It was just a little easier because it was a little easier than doing like pointer plus plus like that, because I need to fit a reinterpret cast in there because they might have different types. So it's just like, this is all it is, right? So I just have the pointer, and it's really just a struct. It's not even a class, right? So I set the pointer with the constructor, and then I just write any t to it, and so it'll reinterpret the t as data and then increment the pointer by 1 t. So that's all it does there. It just saves me from having to write like reinterpret cast everywhere. Yeah, but anyway, this is like very unsafe and easy to break, like if things get optimized out. So I want to change it around to be a little more useful. So I want to get rid of that pointer writer thing, but in order to do that, I need to like enumerate the member types in the push constants when I'm doing reflection on it. So I'm trying to figure out right now with this documentation. So this actually has to be integer like this. Guess whatever. Unsigned int. Actually, I'm using uint32t, whatever. 0 I is less than, so member count is type dot member types dot size plus I. Yeah. So now I just want to print the names. Let's see if this works. Print comp get and the name. And this is type dot self. Okay. And I. I should be doing, yeah, push const name is here. Let me actually do this down here. And then, I guess I won't do that. I'll do, we'll put a comma here. And then, that's fine. Yeah, that should work. So let's see what this outputs. If I get the names, then great. Yeah, okay. So push constants, frustum data. Yeah, frustum data. Hold on. Need to add a space in here. Name and then constants. There we go. That should make that more clear. Oh man. Hold on a second. I gotta blow my nose out. I don't know. All right. So frustum data const is frustum, and then frustum data constants to logic count. Why is it like that? Oh, right, because what? Hold on, that's weird. So is there like one of these per? Or yeah. Put something up here. Constants for shader path. There we go. Oh, can't see. Yeah, this is still a little confusing what it's outputting. Okay, yeah, so this is for one shader. And then, okay, so it looks like I'm iterating over each of these. So each one of these push constant buffers, there's actually one of these per, or no. Yeah, okay, I'm iterating over the members here. Yeah, okay, this actually makes sense. It's just that how I'm printing out is a little confusing. Yeah, that's fine. I'm printing out the buffer name every time. So that's good. So that gets me the member types. And then I guess, yeah, so I need to make a map that has the names to the sizes of the offsets. The offsets, yeah. let's go in shader. Let's say unordered map of, I guess, just strings to size t, and this is push constant offsets. Now, let's say push constant offsets of, I shouldn't have written that code for doing the name. What was that again? Comp.get member name. Oh, actually, let me close that. I don't know if I had that up yesterday. No, I don't think so. Anyway, get member name. Type.self and index is I. So that'll be the name, and then I need the offset. Can this just tell me the offset? Yeah, great. Type struct member offset. So it's this type and then this index. Okay, so that should be reasonable. Yeah. Then I guess do this, or it's here, standard. Const reference, const return, push constant offsets. Why is this? Oh yeah, I forgot. There we go. Now we can get those offsets in the render graph. When am I actually creating? Yeah, it's in load shaders up here, I think. Yeah, or no. Somewhere I'm actually creating the size, or I'm creating the like CPU pointer to upload the push constants to. Is that in here somewhere? Yeah, set push constant. Oh, man. Yeah, push constants. What? How was it here, but it's not in this one? It's not going to be in a renderer, is it? No. Where am I allocating the memory for these? Does this work? Oh yeah, not pipe. Or whatever else you scrap. Or man, I'm tired this morning. Okay, where am I actually setting these? Oh, right, it's in this header file. Yeah, because this is like a template or something. And so I put in the header file, but it's just terrible to have it in here. Yeah, I probably want to change this around and pull this out of here. Anyway. So push constants of shader push constants name. Right. And then I want to do this. So yes, I've got this shared pointer that has the like global push constant range for the push constants named a certain thing. And then what I want to do is be able to just say like push constants of whatever name, frustum data of frustum equals frustum or whatever. Right, but then this has to be, maybe it doesn't, maybe it won't work like that. I might have to have like a function, right? So like, well, yeah, set push constant, except it'll be a little different. So I'll have frustum data, and then instead of like trying to set the whole thing, I can just access a member and then say frustum or something. Yeah, something like that could work. So then when I'm setting it, yeah, would I need to keep track of the shader or just keep track of the, yeah, I just need to keep track of that. So, I guess this push constants here, or I'm already in the header file. So this can be like a pair of, so we'll have the pointer, and then it'll have, yeah, it'll have that map. Basically, it'll just kind of copy the map from the shader, I guess. String to size t. Yeah, this is terrible, but should work. Right. So this should be like this, and then shader push constant offsets, I think. There we go. Add node, so this needs to be first get, I think. Yeah. Yeah, and so this is actually adding the node for pushing the push constants. So I need the pointer there, so that's good. And then I want to change this set push constant function. Where is it? Yeah. So that just gets the pointer. I shouldn't even be getting the raw pointer anymore. And then set push constant. So this has a name, and then another name. What do I want to call these? Buffer name, constant name. So push constants, a buffer name. Say auto constants. I don't know. Should just be this, and then let's have the t data. So what I want to do. Yeah, at the very least, I want to say constants first get is this, except this is going to be a character pointer. I'm not actually going to set it like this. Right, so I have, right, so this is like the base pointer, and then I want to add the offset. Constants dot second of constant name, expression result unused. Yeah, so there I've added the offset, and then I just set that to data. And then, but then is this right? Character pointer? No, then I have to like dereference this. I want to dereference it after doing this stuff. Yeah, I think this makes sense. Yeah, so get the raw pointer, reinterpret it as a character pointer, and then add the offset in bytes, and then dereference it, and then set data. That seems good. Yeah, and then the only thing I can think of is that might have a problem is like if some push constants don't have like if the buffers are named the same but they have different values in them between shaders, then this could get a little weird because it's like it'll allocate the push constants for like the first shader, but I think I need to add like a warning or something in here. So like if the push constant doesn't exist. So yeah, if say if constants dot second of or dot count of constant name is equal to 1, then do this. Otherwise, just say warning push constant. Let's say buffer name dot constant name doesn't exist. Skipping. Okay. That seems all right. Yeah, so make sure it actually exists, because otherwise it would like it might try to. I think if you like try to get something in a map that doesn't exist, it'll default initialize it to 0, which is kind of annoying. But yeah, checking it here, that'll work, and then I'll just skip it if it doesn't exist. Okay, and then I just need to change around everywhere I'm using that pointer writer mess. Yeah, so this here. So what I should really do is say render graph set push constant. So the buffer name is instance count, and the constant name, I think this is like total instance count or something, and then the data is this. I think that's right. Let me check the name. Set push constant, instance count, total instance count. Yeah. Yeah, that's right. And so these all would need to be the same, and yeah, it looks like they are. Yeah, okay. So that's good there, and then I also am using that here, down here somewhere. Yeah, set push constant. Okay, push constant, yeah, okay. So, let's say set push constant. So this is in here, and this one is called, light count. There we go. And then I'm not doing this anymore. Instead, let's say set push constant. Frustum data. Say frustum is cam frustum. And then frustum data, total object count, I think. Yeah. Total object count is this. Okay, now I did think of something. I am depending on actually giving this the right type. So like if I were to pass a size t in there instead of uint32t, then there would kind of be a problem. I'd probably still be able to overwrite it, but this is still a step in the right direction over that pointer writer. Yeah, because otherwise, reinterpret cast, character pointer. Do I need another reinterpret cast? Or can I just dereference the character pointer? Oh yeah, hold on. I probably need another reinterpret cast after incrementing it. Reinterpret cast be a t pointer after doing this. Yeah. There we go. Because otherwise I might have only set like the first character bits or something. I'm not really sure. Might just be undefined behavior, but that's much more clear now, even if it's verbose. Yeah, so let's see what this does now. Okay, I'm still doing this somewhere. Line 78. Okay, set camera consts, custom const. Right, I thought I'm not doing this anymore. I never use name casts because they're so ridiculously long. Yeah. But I think like reinterpret cast is better than, it's like faster than doing this. Or no, because like I think doing this will like actually try to do a type conversion, but reinterpret cast just like it just treats the block of data like whatever you tell it. But this will actually like try to do type conversions and stuff. I think that's how that works. I'm pretty sure I'm not using this function anymore. Because I have that other one now. This was for the other calling. But now this says something else is broken. Apparently not. What is it not like in here? Oh yeah, template, whatever. That doesn't matter. That's just something I need to update to Clang 19 to fix. Actually, hold on. I did. So there's something I came across earlier. Where was that? Let me see if this works first. Okay. So that looks like things are correct. Okay, and I didn't get any weird errors. I didn't crash or anything. And all this looks reasonably correct. And I can still, yeah, I still look away and everything's 0. And I look at this. C-style cast subpointer, same as reinterpret cast. Oh, okay, I didn't know that. I thought it would try to do like type conversion. But yeah, this works, so that's good. And then if your value is not a pointer like casting it into a float or something, you just take the address and deref. Yeah. Yeah, no, I'd be a bit safer because reinterpret cast is like it's kind of dangerous. Yeah, but that might be slightly safer. I'm not sure. But anyway, there was something else. Where was it? Is it in here? I don't remember. There was it's awful. Okay, yeah, it's in shader. So, oh yeah, it's right here. Yeah, yeah, if I run into an unsupported size, yeah, I'll leave this warning in here. So this is actually like a Clang bug. And so, yeah, I really shouldn't be returning anything here because I'm just doing a runtime error. And so Clang should be able to tell that this will, if I get to default, it'll never return. And I think it works. I'm pretty sure this works if it's not a Lambda function, right? So if I just put this here, and I say, what PK format, size to format, like this. Oh no, I'm still getting non-void function does not return a value in all control paths. Yeah, because I've had stuff before. Yeah, lambdas are bugged. Yeah, but this isn't. It's still happening here with the switch case because I'm pretty sure if I were to say like if effect size equals 2, else if effect size equals 3, and then if I just don't even say else or anything, right? Oh no, I know what it is. I forgot to say throw runtime error. Yeah, there we go. That's my fault. It's not a Clang bug. Yep, that was actually the warnings telling me correctly. Yep, and you say throw runtime error. Yeah, I guess it. Yeah, the warning was just a bit misleading because it was saying like does not reach end of control path. Um, yeah. Anyway, that's my fault. Because I have run into other Clang bugs, like with this stupid thing with the whatever it is in here. It should load and start freaking out, like right here, or not. But yeah, it's fixed in like Clang 19. Yeah, it's this template argument is different template parameters. Um, yeah, I ended up filing a bug report a while ago, and it's fixed in Clang 19. It's just I'm on NixOS, and like the default Clang is 18 right now, or 17, I don't remember. So like I think I can switch to unstable and then use Clang 19, but I just haven't got around to it yet. So yeah, then we're actually doing push constants in a slightly less horrible way now. So safer push constant writing. There we go. So now I can just go here and set this to be just true like this. And then I should get a warning. Yeah, I shouldn't have to recompile anything because it's just a shader. And I should get like a warning down here. No, I did not get a warning. Okay. That's weird. I should... Maybe it didn't optimize it out because I'm running it here. What if I... Maybe I disabled optimizations earlier and I don't remember that I actually did that. Optimize... No, I'm optimizing it. Yeah, it actually should get optimized out. And so this is also kind of weird. So all these are green, that makes sense, but this stuff is red. So that's something else. But honestly, like, I should be getting an error if this is getting optimized out. Yeah, like all this PN test stuff should get optimized out. And so the frustum should get optimized out. And so it shouldn't exist. Let me open that in render doc and see what the shader actually has. Why are they not getting cold if they're red? Yeah, that's enough. Like they should be getting cold if they're red. And so it might be like a problem with how I'm like getting the data for it or something. But like the boxes are right, so I don't know. But let me see if I can get a warning message from the push constant, and then go from there. Yeah, so dispatch. Do I really need 977 of these? Maybe. Yeah, I might have these group counts a little wrong. Right, I just wanted to view the shader. Push constant frustum data. Yeah, so the push constant is... the frustum stuff is getting optimized out, but I'm not getting a warning. Yeah, I'm reading it from the SpearV, not from the GLSL. For doing reflection. But I should be getting a warning because I'll be trying to set a push constant that doesn't exist. If constant second count, constant name is equal to 1, else warning. Yeah. That's weird. Getting offsets for push constant. This. Oh, I am getting warnings. Okay. What? Why am I getting warnings now? Oh, okay. I don't know. I swear this wasn't showing up earlier. Maybe I was just like I think it starts on like the first frame or something, and maybe I expanded the window before it showed up. I don't know, whatever. So that does work. Maybe I don't want to spam that every frame, but whatever. Yeah, let me just make sure this is all in the latest, whatever. Yeah, so it is outputting that, so that's right. So yeah, I need to figure out what's going on with the bad colors. So object.instance is offset. Yeah, that makes sense, right? Yeah. So like I'm getting the right bounding box. And then yeah, and the culling is actually finished, right? So the visibility buffer has been written to correctly. And then I'm just looking at this specific object and looking at its instances offset, right? And so like since all these are going to have the same value, I just look at the first one, right? Yeah, and this is like in the shader, it is like instances offset starting at 0. Objects of index, yeah. And so it should be visible. So let me also render doc again. Let's see what's going on. Everything should be visible. Except these are red. So yeah, let me just look at you look down here. I draw the boxes. And this takes in the visibility buffer, yeah. So all of this is ones. Maybe I shouldn't have so many objects. Yeah, hold on. Let me get rid of all those extra, or at least most of those extra boxes, because that's just making things harder to debug. 10 and 10. That should work. Run it again. There we go. Yeah, so everything should be green, but we've got some red. So this is when I draw the boxes and I read from the visibility buffer. Okay, so look at this. Some of these aren't right, but everything should be 1. So what's going on? If I look here in the compute shader, here, yeah, so like I think this is after this thing runs, yeah. It's not quite right. And there should be one of these per instance. Yeah, I guess it's all the same thing. Yeah, I don't know if like RenderDoc tells me if it's showing me like the state when the shader ran, or is it like the global state? It might just be the global state. I don't really know. But yes, definitely doesn't look right. Isn't there something like I can step through the compute shader? Yeah, debug. Debug thread. Well, let's see one of these broken ones. Thread number 8. Debug group 0 thread 8, I guess. So yeah, get 8 out of there, and then execute forwards is F5. All right. Oh, that did the whole thing. Step forward into F11. Okay. So total object count is, so we got 17 from the first. What? Oh, yeah, that makes sense. Yeah. Yeah, so that's true, right? So like this is the if 34 and 34. Yeah, so if it's in range basically. So that makes sense. And then objects of 17, which is 8, which is, 16. Yeah. Okay. So I'm getting objects of 8, and then getting all this stuff out. And then what are 93, 94? So 94 is 1. So yeah, one instance with an offset of 9. Offset of 9. Okay, so hold on. So I actually need to go back to the other one, to the other thread. I want to look at, because this one's going to start at 9. Right, because he's going to have multiple. Yeah, that's annoying. Close that. Debug. So let's look at thread 7 then. What was it? F10 or F11? Yeah. So, okay. Yep. So now I'm looking at, it should be writing to element 8 in the visibility buffer. Yeah, because the offset the offset is 8 and the count is 1. So that makes sense. If that break. Wait, what? Did it break out of the... No. So, yeah. Yeah, it ran once or twice. How do I go back? Backwards into Shift F11. Okay. So, right, so while true. Okay, so I guess this is just how it's doing a for loop. Yeah, if not 66 break. Okay, and 66 is true, yeah. So that's fine. And then 78 equals 93 plus 95. Okay, yeah, and then I'm indexing at 78. And then 93. And what's 95 is 5. Okay, so this is like that that index variable or whatever. Yeah, so this is if I is less than count. Yeah, 95 is I. Okay. Yeah, so then go into the object instance IDs 78. And then write to the visibility buffer at 81. Or wait, no, but then that's 7. Okay, so it was number 8. Hold on. 81, 80. Okay, so 78. Pull up the shader. Yeah, so I'm looking at object instance IDs of this, and that's where I'm writing the visibility buffer. Okay. Then I can shrink this a bit. There. Now I can actually see what's going on. So, yeah, so this is instance offset plus that. So go next, and then now 78 is 8. So I'm looking in this buffer at spot 8 in object instance IDs of 8. So pull that buffer up. So look at this, I have 2 zeros at the beginning. So that seems a little odd. And this goes up to 9, 10. This might just be like another little off by 1 error. 6, 7, 9. I don't even see 8 in here. Yeah. It's pretty weird. Yeah. So object instance IDs of this. Yeah, so what is this? This is the Or you know what? Maybe this isn't right. Maybe it needs to be like this? No, because the instances aren't guaranteed. No, they should be sequential. But, I mean, this is theoretically better, I think. Yeah. Like, they should be sequential in the visibility buffer, but this is slightly better anyway, just in case. Yeah, yeah. Yeah, because I guess there could be cases with multi-threading where they aren't sequential. So yeah, I want to get the object instance ID. Right, so this maps from the instance count of an object to a global instance ID. Yes. And then, yeah, and then so I look at this visibility buffer and I get like 7 out of here. So not even writing to the right spot, but yeah, like the fact there's 2 zeros here is suspicious, and I don't even see 8 in here. And yeah, like it's multi-threading, so it might be down here, but it's not even down here anywhere. And then there's like this jump up to 45, but maybe there's stuff down here. Or, okay, no, yeah, I guess like there should be one of these per like object count or something. Yeah, so it actually does make sense for there to be jumps here. Yeah, yeah, okay, so this means that whatever's at 7 should have a count of 2, I think. Right? Because then the next, because this will do like 7 and 8, and then the next one is at 9. But what was the count here? Isn't this just 1? Let's count. What's 94? Yeah, 94 is just 1. Okay, but then this starts at object instance IDs of 8. Yeah. So the instance count should be 2 if there's a 9 here. Oh, man. Yeah, just more little off by 1 errors. Very confusing. Right. So object instance IDs. So how that works is I have the offset and then the count. Yeah, so it's the object's instance IDs. Yeah, that makes sense. And then I look in the visibility buffer with those instance IDs. Okay. So that's like fairly straightforward, actually. I'm not sure how I'm getting that wrong. I look in object. Instance IDs allocation. Yeah, and like there's some stuff about like removing things, but I'm not removing anything right now. So this shouldn't be the problem. I tried disabling the extra threads. Maybe that'll change something. Yeah, but update this. Yeah. So I want to write the instance offsets. Yeah, and then these instance offsets are, yeah, offset by basically whatever first instance ends up being, right? That's what, yeah, instance index offset divided by size of. Yeah, that makes sense. And that's not going to change until I start like removing indices. Divided by size of uint 32t. Yep. Index offset. Yeah, so I'm adding this to here to turn this from like a local offset to a global offset. Because this is just the, yeah, this is the local offset. And this is like, it's offset within the parent. Okay. Divided by size. Yeah, I mean, the size here should be fixed, but just to make sure I can do that, I'm pretty sure that's not the problem, because it should be doing the same thing. Yeah, so that all looks good. And then I want to allocate something of buffer with the size of this times size of U32T. Yeah, that makes sense. And then I want to write these to it, to that allocation. And then when I go down here, I want to write, yeah, to the object calling data. But where am I? Don't I need this offset or something? Or where am I getting instances offset from? Okay, yeah. It's this thing's offset divided by size of U and 32T. So that makes sense because these are all U and 32Ts. Yeah, so that all makes sense. Oh yeah, and then look, so I've got this here, right? If I have like 0 instances offset or capacity, right? So like I should never, if I'm writing 0 here, then I should be getting a warning, I think. Or no, that's 0 size, not if the offset is 0. Yeah. So let me see what happens after dividing that. I don't think this will fix it, but rebuild it. Yeah, no, it's still pretty broken. Open this up in RenderDoc. Yeah, visibility buffer. Yeah, so we've got, yeah, okay, and then this actually does start at like 1s, but then we've got other things. And also the fact that these aren't getting cold is strange. Like, yeah, they should be getting cold if they are red, like given this visibility buffer. So am I doing something wrong? Where would it be? Yeah, frosting. Yes, there's, yeah, here's cold visibility buffer, right? Yeah, but I'm saying if visibility buffer of index is equal to 1, so that seems fine. Like I'm not doing, yeah, I don't know why these aren't getting cold. That's also really weird. Because it's not like, it's not a problem with drawing. Because, like, I guess the drawing is actually drawing it correctly because these should be getting cold because these are not equal to 1. So why aren't they? That's weird. But then, like, sometimes it does work. Like, when I look away, it actually does set the instance count to be 0. So strange. I think first I just want to resolve why this is broken, and then I can go into resolving that. That's not the right one. Yeah, so instance IDs. Yeah, so this is still messed up. I want to disable multi-threading. Yeah, that's I also want to do. So now we don't even have multi-threading. Save. No, yeah, I don't think. Yeah. Okay, yeah, so it's still red, so that's not the problem. But open it up here and just eliminate that as a possibility. And everything should be getting drawn because I'm forcing it all to be true. Yeah, so visibility buffer, yeah, that's messed up. And instance IDs. Okay, so this is still messed up, so it's not a multi-threading problem. Okay. So which one of these is wrong? So element 8 here, right? So I'm writing to visibility buffer element 8, or maybe I'm not writing to it, right? Because there's nothing in here. Where's the, pull the object calling data out as well. Yep. So which one of you are writing to number 8? Okay, yeah, so you have an instance that's offset of 8 and a count of 1. So, okay, so element 7. Yes. Okay, and then this instance's offset starts at 1. So that's a little weird. But, I mean, I guess it... Yeah, it probably doesn't really matter that this starts at 1 because, like, so I have like an extra thing here, but it should be fine. Because I'm actually like using this offset to index into things. So the fact that there's a 0 here isn't a problem. This is a problem somewhere else because I don't want that extra 0 there. But yeah, but that's not actually where the problem is. So yeah, and then so I have these like 10 objects here, I guess. 1, 2, 3, 4, yeah, 0 to 9. Yeah, so these are the 10 cubes. Okay. And then, what is it? Yeah, so one of these cubes should show up as red and the rest of them are green. Yeah, so I have one red cube or one red, like they're all red. I think you know what I mean. Yeah, so the rest of these are green though, but this one's outline is red. And so that one is going to be this number 8 cube, which comes from this number 7 in the object calling data. Okay. Yeah, and this object instance IDs, right? So if I look at instance offset plus instance count, it should just be like 8 plus 0, right? So if I look at index 8, then that's index 7 in the object instance IDs. Oh, man. Yeah, but like I don't see 8 in here, which I think is the problem. And maybe it's because of this stuff, because this is off, but I don't know what's going on. Like, I don't know why just one of these would randomly not work. It's kind of weird. Okay, but then here, look at this. Both of these start at 9. So that's a problem. So maybe that's where that extra spot is coming from, because both of these are at 9. So, yeah, then this object calling data is broken, because I have 2 at 9. I'm not removing anything, so it's not that. What's up? Hey, currently, so I'm working on my game engine, and I'm trying to get frustum culling working. But I'm having a problem where some of the indices I have, I'm like, how am I? I'm good. Oh, yeah. Okay, it's just the chat delay. And so some of these indices aren't correct. So like if you see here, like both of these are 9. And so I'm not writing to the correct spot to determine if an object is visible or not. And so if you look here, this is just like a screen capture of, do you use Python? No, I'm using C++. Yeah, but that's like a visualization. So anything that its bounding box shows up in red, then it should be getting cold. So it shouldn't actually be getting drawn at all. But the stuff that's showing up in green is stuff that should be getting drawn, right? So that's showing up in green here, that's fine. But like the fact that this has a red bounding box, but it's getting drawn, that's a problem. But now really the bounding box should be green because it's on the screen. You love Python? Oh, yeah, I don't know. I don't know. It's all right for like scripting stuff, but I wouldn't want to write a game engine. My favorite language, I guess just C++. That's what I've used the most. I like Haskell a lot, but I don't use it all that much. Yeah. Yep. So anyway, yeah. So these bounding boxes should be green. Do you like to play games? Yeah, yeah. I'll play video games. I'm just not. I haven't really done anything on stream playing games yet. Um, but I might eventually. But yeah, right now I'm just working on my game engine on stream. So, yep. So these are both 9. So that's a problem. And then I've also got this weird extra 0 here. And maybe these are related because I'm like, I don't know, allocating an extra spot or something. And I'm not actually writing to it. I'm not quite sure. But yeah, these should not both be 9. So I disabled all the multi-threading, so that's not the problem. You also like to play Minecraft? Yeah, I'll play Minecraft as well. Usually I'll play like modded Minecraft, but yeah. Never get bored playing Minecraft. Yeah. All right. So yeah, so somehow, so I end up writing it here, and I end up writing the offset here, and so this is the allocation. Do you want to get rich? Are you trying to sell me something? Because I'm not really interested. Oh, just I don't know, work hard and be a good person, I guess. I don't know. I'm not rich either, so I'm not exactly the person to be asking. Um, all right. So anyway, got this allocation offset divided by the size. Yeah. So then that means that somehow these have duplicate offsets, maybe. Yeah, I'm going to, whenever I write this, I'm going to dump the offset. So got offset data dot instances offset. Like Andrew Tate, you want to learn $100,000 a month? All right. I mean, go for it, I guess. Okay, well, these warnings are spamming, so let me get rid of those. So, yeah, probably just need to like only do these once. Yeah, figure that out. Okay, yeah, so got offset. Okay, yeah, so both of these have offset 9, so that's not right. Very interesting for talking. Oh, thanks. Um, where? How did I? KDE doesn't like me clicking on this. Yeah, so both of these are 9. So it's definitely a problem with my memory allocator, I think. So how could both of those be not like? Why is it just these two? Like that's what's really weird. Let's go to object. Yeah, so I got offset. Yeah. Since ID's allocation, you were looking at my channel, realize I don't have a logo and overlay. I mean, I'm not looking at, yeah, I'm not looking at buying any art or anything like that. So you can send me something, but I'm not interested in buying anything. Yeah, so this offset, yeah, so this is like the offset I'm getting from the memory allocator. Yeah, instance IDs allocation. And I'm not doing multi-threading. So then how did this break? I don't understand. Let's see. Allocated instance IDs and got byte offset. Checked instance IDs allocation offset. Not here for selling you so many clients. Just give you offer you don't want. Yeah. Yeah, I just you can send me something, but I'm not gonna spend any money. Yeah, don't buy. Okay, yeah. I could give you a good review or something. Uh yeah. Discord. Okay. Yeah, I'll look at that a little later. Okay. So one thing is the first time I'm allocating this, it's giving me a byte offset of 4. So that's something wrong with the allocator here because it should be starting at 0. And other than that, so this is 4, 8, 12, 16, 20, 24, 28, 32. Okay, and then both of these are 36. So that's another problem. And so that's why both of these are 9 down here. And so what kind of allocator is this? This is a linear allocator on top of a GPU allocation. Okay. So there's definitely a problem with my linear allocator code. All right. Can you add me now? Projects can check out the stream. I'll add you. I'll add you after I break in streaming. I'll add you about 2 hours when I take a break, and then you can send me something, and I might leave a review or something like that. But for right now, I do want to focus on my stream instead of kind of getting sidetracked with all that. Anyway, so offset plus equals byte size. So maybe that's why I'm starting at 4. Well, hold on. So free blocks dot size. Yeah, no problem. Yeah, okay, and this probably isn't thread safe because I have to do safe vector in here. So that's something. But I disabled all the multi-threading, I think. I'm pretty sure I disabled all the threads, but I'm going to put a mutex lock in here just to make sure. Mutex, I don't know. Yeah, so create that parent, that's fine. The rest of these, I want a unique lock, mutex, lock, mutex. There we go. So this will ensure that, yeah, that's fine because I'm not doing free down here. Yeah, I'm not doing free down here anymore, so I can do this. So that all works. Yeah, have a nice day. So, I mean, I guess I'll just run it with that mutex lock and see what that does. But I should have disabled all the multi-threading, so I doubt this is going to fix it. But yeah, this does need to be thread safe anyway. What is this? Yeah, it's still 36. I thought I saw... Okay, yeah, that's just validation layer stuff. Yep, so it's not, definitely not multi-threading problem. Okay. So let me see. So let me try to fix this starting at 4, because it should start at 0. And it's probably just because I'm doing like plus equals here. Let's go to object and let's see where this is actually coming from, right? So it's object instance IDs allocator. This should come from Object Manager. Yep, so I'm just making a new linear allocator on a buffer. I'm not allocating anything. Yeah, so all this does, yeah, all that create buffer will actually do is it'll just run this constructor, but it won't actually create the GPU buffer or anything like that. It's not until I call alloc that it'll actually create the GPU buffer. Okay, and then I only call alloc when I actually try to allocate some space from it. So it's like lazily allocated. And that's why there's this alloc 0, like, yeah, if like I need a sub allocation, but I don't want to actually allocate the GPU yet, something like that. Anyway, but I'm calling alloc on here for every object. Yeah, and so I'm giving it, yeah, just a byte size, whatever, right? It's a non-zero byte size. So I go through here and I should have 0 free blocks, right? So I have 0 free blocks. I should go down here. Then I should say sub allocation. So parent size should be 0. Then byte size should be the block size. So yeah, they should have an offset of 0. So why is it starting at 4? Let's say allocating new linear block. Actually, might want to move this. Yeah, allocating new linear block. Let's just say block offset. Yeah, block offset. And then size, or this is byte size, is block size, and this should be offset. Why is this? Oh, there we go. Man, a lot of things to read. But why is this going so slow? It's like Emacs was slowing down too. I don't know. Whatever. So let's look at what's going on here. It's terrible. Alloc instance IDs. Okay. Alloc instance IDs. Allocating new linear block. Right, am I pre-allocating? Oh, right, I'm pre-allocating those. Yeah. Alloc instance IDs and got byte offset 36. Okay, maybe that's like, right, because I'm pre-allocating those. Let me go in here and say pre-allocating instance IDs. Right, so it's really suspicious here that like, okay, so this is allocating byte size of 40 and then starting at 0. And then, so here I'm offsetting at 4. And then 36 is when I start skipping or duplicating, right? So I think it's definitely got something to do with that. And so I just want to make sure that I'm looking at the right thing. So I want to print out when I'm pre-allocating. So yeah, pre-allocating instance IDs. What? Yeah, I'm printing this out before. Why is this coming after? What? I don't know why it's coming after, but I'm like fairly certain it's this, right? Because then I just do allocating instance IDs and I'm not doing a linear allocate. So it's definitely looking at this. And then, yeah, then I come down here and then I do allocating new instance IDs, got byte offset 40 or whatever. And then byte offset 500. Yeah. Those numbers seem very wrong as well. Like I shouldn't have that. Yeah, these are definitely not right. Byte size. Right? Or I mean, these might be for the instance data, but still I don't think it should be this big because this is yeah, this would be like 2 gigabytes, which is not right. Yeah, this is like, or no, this is megabytes. Yeah, this is or yeah, this is like 10 megabytes. Okay, yeah, it's not gigabytes. Um. Anyway, let me try to fix some of this first. So I don't know why this is showing up before. I would think it would show up there, allocating new linear block. Yeah, and it shouldn't go until I actually try this. It's really weird. Is it because I'm doing model pre-allocate? Maybe it's model pre-allocate. Or we go to this and let's say pre-allocating model. Pre-allocating instance IDs. Allocating instance IDs. Byte size. There, something like that. Okay, so it's pre-allocating model. And then it just doesn't even do anything for here, which is, I don't understand that. Oh, maybe it's, no. Am I like not printing it at the right time or something stupid? No, that's when I'm allocating a new block. Oh, yeah, I'm not calling it on pre-allocate. Oh, yeah. I'm only saying this here. Yeah, that's why. Yeah. Pre-allocating. There we go. Man, just trying to get the debug print statements working right is a mess. So, okay, yeah, there we go. Pre-allocating new linear block. That makes sense now. Okay. So I'm pre-allocating with a byte size of 40, right? And then I try to go here. So then I try to allocate some instance IDs, and then I start at 4. And I'm pretty sure that's because I'm saying byte offset. Right. So I go over all this, and I look at a free block, saying, hey, is the free block size greater than the byte size? Yeah, and then here's like when it's equal. So if the free block size is greater than the byte size, then I want to increment the free block's offset by byte size, and then set its size to be this. Okay. But here I'm saying free block offset, and this is after I increment. So that's why this is off. So this actually needs to be, I guess, minus byte size. Or it's probably better if I just store in a variable. Let's say size t block offset equals free block offset. And then I can increment that, and then I can just use block offset. That's a little more clear about what's going on. There we go. Yeah, otherwise I could like put this into a pointer. Maybe that's better. I turn this into a pointer and then I increment. Anyway, does this look any better? Well, okay. Well, now I've got a green box around all of the around all of these. So that's definitely a step in the right direction. Yeah, definitely. So that was one problem. So let me actually just say auto block equals this, return block, and this should be free block offset. There we go. I think that's the right way to do this. All right, so make the block and then decrement the free block and then return it. And otherwise, if they're equal, do it like that. All right, so run this again. Oh, what's this? Offset. Oh, right. Yeah, so that all still looks good for those boxes. And if I look at, go up here, yeah, so now we're doing 0, 4, 8, 12, 16, 20, 24, 28, 36, 32. So that looks good. And then do we still have, we shouldn't have that like duplicate problem anymore. Now instance size, yeah, but I should probably, yeah, let me get rid of these print statements so I can actually see what's going on. Yeah, object manager, get rid of this, get rid of this. I just realized I forgot to commit the push constant changes, so I'll do that in a second. Okay, this is still messy, but yeah, it's definitely better. Yeah, got alloc instance IDs and got offset. Yeah, so all these offsets make sense now. So that all looks good. Yeah, and then got offset 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, and then this is just like however many instances things have. That's why it's going up like that, times 4 because bytes. Yep. That looks good. So is this back in object? Yeah, got offset. And then alloc. Okay. Let's see. Yeah, there we go. So now I want to go ahead and commit the push constant stuff. I'm not sure. Is this? Yeah. So this warning, I guess I don't want to print this every frame. I just want to print it once. So I guess I need to keep track of something else and say unordered map of strings to bools and just say did print push constant warning. Yeah, it's fine. Yeah, really it should be a map of maps, but I'll get to that later. Else if did print push constant, or hold on, is this how I want to do this? No, I think what I want to do is just have a set of, I shouldn't have changed the name, but yeah. It's just called printed push constant warnings. And then if printed push constant warnings dot count of, yeah, I guess I'll just do constant name. Really should be like buffer name plus constant name, but whatever. Dot count equals 0. Then print the warning. Then add it here. Dot, insert constant name. There. So that should only print it once. Okay, then let me commit this push constant stuff. And yeah, maybe I'll commit the object stuff since I fixed the linear allocator. So let me just git add -p. So let's not do any of that. Let's not do that. Yeah, I'll put the mutex in there. That's fine. Yeah, that doesn't matter. I'll do that in another commit. Okay. So this is linear allocator use correct offset when returning block. And then what else? So not that, not that. I could probably undo that. Oh, we did commit the push constant stuff, I think. Yeah. Okay. Only print push constant warnings once. And then what else? Let me go into object and just put this back to how it was. Or no, this one, right? Instance alloc app, whatever, I'll just leave it there. That's fine. Yes. Ensure size of t always used for object index offset, whatever. Okay. And the rest of this is just changing settings, basically. So, yeah, so this is like mostly working, except we still have this problem of this is still red. Why is this red? Because, yeah, these boxes are all working correctly now, but that's still red. So open up RenderDoc, load this up again, and yeah, so everything's visible. Let's see what's going on. Compute shader, so visibility buffer. Okay, so we still have stuff that's not 1. So all these should be 1. And they also shouldn't be getting drawn because they're not 1. But right? Or yeah. I don't know why they're getting drawn. Like, this is also weird because I'm saying, yeah, visibility buffer of index is equal to 1. So I don't know. I don't know. It's weird. So let's look here at the calling data and then instance IDs. So this, whatever, yeah. Anyway, object instance count, instances offset. So yeah, so these all look fairly reasonable now. Yeah, 10 plus 115 is 125, 26, 127, 128. Yeah, 177, that makes sense. 178, 180, 181, 182. Okay. So that looks good. So then I should have 183 entries in here. Is that correct? Hold on. So this is instances, yeah, so this is offset 182. Okay, yeah. Offset is 182 and instance count is 1. Right, so this is just at index 182. So this is actually correct. Okay. And then we don't have any multi-threading, so these should all be sequential. Object instance IDs. Why do these have gaps? That's weird. I wouldn't think these would have gaps. So that might be a problem. 9:45. Okay. Yeah, I guess it's supposed to have gaps. And then it goes down to no, but then like we have 25. Like, let me jump up again. Okay. Yeah, so this is all screwed up, right? So number 10 is screwed up, right? So this should be 1. Why is element 10 in visibility buffer not 1? Well, in here. So this would be object instance IDs of object instances offset of I. So in object instance IDs, which one of these has 10? So 10 isn't in here. So that's weird. We don't have 10 in here. And so that's why it's all messed up. So why would 10 not be in there? Right, because I have 10 in here. An instance count. Yeah. Like, I don't know which thing this is, but yeah, we should definitely be setting 10 because we've objects instances offset. Or hold on. So this is instance IDs. Okay, yes, instance IDs of 10, right? But object instance IDs itself doesn't contain 10. Yeah. Yeah, so these should be sequential. Okay. So yeah, what's getting written in here is object instance IDs. So is that this or no, that's this up here, index offset. Instance IDs, right? Instance offsets dot data. Yeah. So these instance offsets aren't correct. Is that it? Yeah, I think so. But object instance IDs. Like, shouldn't there be one of these per instance or no? What? Confused how this is supposed to work. Get confused every time I look at it. So what this is supposed to be is the list of instance IDs per object. Yes. So I'm supposed to be able to iterate, right? So I'm supposed to be able to go to like instances offset plus I. And then each entry will be another instance ID for this specific object. So this buffer should have the same length as the number of instances I have, which would be the same thing as like the visibility buffer. So this, right, but see, this is way bigger, right? This is 910, so I have 910 instances? Is that right? Because that seems, oh, maybe. No. Because like the instance counts are here, basically. It's this, oh, you can't even see this. The instance counts, I'm pretty sure that's like this second number here, right? Yeah, instance count is 10, right? So like the sum of all these instance counts should be however many instances I have. So why does visibility buffer have like 910 entries? Because I should just have one of these per instance, right? Yeah. But I know, where is it? I'm setting the size of it. Is it here? Yeah, I'm setting the size, yeah, of it here, which is like the size of instance indices. Maybe, am I like confusing byte size with regular size? No, that's 3644. Right, but then this is 182. No, it's not 182 times 4 or something. No. Yeah, I'm just trying to match the buffer sizes. So I'm like getting the size here in bytes, and I'm getting the buffer, and then if size less than size, then realloc to be size. Yeah, and this should like just happen. Well, this should happen like whenever the buffer changes size on every frame. So that's fine. Yeah, and realloc, it's not like grow, like it just reallocates the buffer to be a certain size. That's all. Yes. A new byte size. Yeah. Hmm. All right, so instance indices, right? So I've like, yeah, so there's one of these per instance. Then let me actually look at the draw commands, because that'll tell me where. Let me look at the non-cold draw commands, indirect commands. Here we go. Okay, so that's why, because first instance goes up to 729. Instance count. That seems weird. Why is first instance so high? Like it should be. Like it should basically just be the sum of instance count. It shouldn't be, which is not 908. Right? Yeah, this should be like, I don't know, 120 or something. Right? I think that makes sense. Let me look at draw. Where am I getting instance count from? Or first instance. Where is first instance coming from? Down here. So instance indices allocator parent offset divided by size of u and 32t. Maybe this isn't right here. But then, like, if this wasn't right, I would think all of the instances would be getting screwed up. But maybe, like, all the instance data. Yeah, like I have like 10 instances here. So we should have like 10 here, but I don't. I don't even see like 40. Oh, no. Or, okay, I see 40. Yeah, divide, but I am dividing it. So instance indices allocator parent offset. So how this works is, yeah, alloc 0. Okay. So I have this instance indices allocator, and this is a linear allocator, I think. Yeah, this is a linear allocator on top of a GPU. And so how this works is, so I have this GPU buffer that has all the instance indices. And then I have a linear allocator on top of that. And then on top of that linear allocator, I allocate these contiguous fixed blocks. Okay. Okay. Oh, right. So I think these actually jump around because of reallocating stuff. So this is actually because of like fragmentation. This isn't because these are wrong. Yeah, it's because I have fragmentation problems. Okay. Yeah. Yeah. Because like, yeah, when I go and I add a whole bunch of instances, then what happens is the free blocks has to like copy this to a new, like the linear allocator underneath it. It has to allocate a new block for like the contiguous fixed allocator, right? And then so when I add instances to it, even if I'm like pre-allocating here, it still has to reserve all that space. Yeah, but if I'm running pre-allocate, well, I'm not running pre-allocate on everything. I'm just running pre-allocate on the boxes. But everything else is not going through pre-allocate, which maybe that's why everything else isn't working. Yeah. And so what happens is so when it tries to allocate new stuff, then it has to reallocate the child block of the linear block that this is based on. And so then that linear allocator will take it and it'll like put it at the end. And then now you have this big fragmentation spot. And so that's why these numbers go so high. Okay. Right, which is why this is so big and I have like scattered data everywhere. But then here, yeah, instance is offset. Yeah, but like this is just pointing to instance IDs. Yeah, and so that's why these jump around. Okay, and these go up to like 9, 10, which is what this goes up to? Yeah. Yes, I think that makes sense. Because 3 of them, 908, 99, 909, 910. Yeah. So that actually makes sense. Except, yeah, so I only have 182 instances. Yeah, I think that makes sense. And then I'd look at object calling data and I'd say, okay, what's your offset, right? Your offset here is 128 and you have 49 of them, right? So it's going to look at like 128 here and then say like, okay, well, I got the next 49 or whatever. But it is going to be looking at like 10 plus 115, right? But if I look at spot 10 here, yeah, so I guess those are fine. These are just random instance IDs for it. Yeah, but maybe there's some weird problems with like things getting reallocated when I'm not updating the instance IDs in here. That could have something to do with it, but I'm not sure. And then visibility buffer. So then I think that's why visibility buffer looks so weird. Right, because... yeah. But still, like, I should be writing stuff. Okay, I'm writing to the visibility buffer at the instance index, not at, like, this index. Yeah, I'm writing to it at this here, just like 45. Okay, so then I think all I need to do, right, is actually translate this. Yeah, that makes sense, right? So I see, I understand why things have been broken now. So these have been read, but they're still getting drawn because I'm looking at the wrong data in the visibility buffer, right? And the reason I'm looking at the wrong data is because I'm not actually translating this object instances offset into the object instance IDs, which is where I'm actually writing to the visibility buffer. I had assumed that this instances offset, like, basically that there'd be no fragmentation within the instance IDs buffer, or really, I guess ultimately it comes down to fragmentation in the instance indexes, which is different from the instance ID. It makes sense to me. Yep. So all I need to do is pass in this object instance IDs and use this in the vertex shader, and that should work. So then to do that, all I should have to do is just grab this bind it here. Yeah, put it in set 1 binding 2. And then I can just say object instance IDs. Yeah. So there we go. And now this should work. Yeah, I should just be able to run. I shouldn't have to recompile. Okay, it's almost working. There's still a few of these that are broken. So that's annoying. But that's a definite improvement. Yeah, and so like I know some like some of these boxes, like they're not actually covering anything, but I think like maybe some of these boxes are supposed to be like here. Because like I don't have a box here. And so I think some of the AABB stuff I'm doing isn't quite right. And I know animations are broken. Yeah. And that also makes sense, like why when I okay, but now when I look away, instances drawn is always 180. Oh, right. because I disabled culling, that's why. Yeah. Yeah, anyway, let me add shaders, graphics, box stuffer. Yep, there we go. Get correct visible instance index in box shader. There we go. So we still have a few of these that aren't working quite right. Because all the fragmentation gets really annoying to figure out. So I think first what I want to do is get the boxes in the right positions, and then it'll make it a little easier to figure out like which models are actually broken. Right, so let me make sure everything's built. Oh, I did have stuff I need to rebuild. Not sure what, but yeah. Yeah, so let's get animations working, and then I think maybe I'm not taking the scale incorrectly or something. The bounding boxes aren't exactly in the right spot. So let's get that working. Oh yeah, I want to see if I turn back. Basically, if I put all this back, does this does everything still work, and is this reasonable? Yes, that looks fine. And now, yeah, I am drawing everything. And so where, yeah, for some call objects. So now I can set this back to actually do testing. Okay, yeah, so all those instances are getting drawn. And then, yeah, and then I can look away. Yeah, now I have 0. Now I have 218,000, yeah. Okay, and then, yeah, so there's definitely some problems, because like down here I can see some stuff that's not getting drawn. Yeah, and there's like some red way back there. Maybe it's got to do with like clipping planes or something. I'm not sure. Yeah, and then those are broken there. But yeah, and then I can barely see, like, I can't even move like slow enough. What is it? Is it alt to slow down? Yeah. So like right there, that is red. And so like technically I should still be able to see that because I can see the bounding box. Since I'm looking and seeing if the bounding box is within the frustum. So it's something not quite right, but it's like, it's so little that I can't actually see it because like the bounding box is bigger than the whole thing itself. I mean, it should be exactly as big as it is, but yeah. Yeah, the bounding box looks like slightly too big, but maybe that's just because of the model or something. It's a little strange. Yeah, and then like here, yeah, like here the bounding box is huge for this little water bottle, right? So maybe I'm not taking scale into account properly. But I know like this model is like heavily scaled. So it is working for scale on this model. Just like not exactly on this model. It's a little strange. Yeah, but this is definitely a big improvement now. And now I've got 700 FPS when I look away. Yeah, okay, and so now it's taking about 1.3 milliseconds to cull everything. So yeah, I think there could definitely be some improvements with like the culling code and all of that. Probably start by condensing that visibility buffer. That should give me like 5% FPS or something, but that's kind of later on. Once I get it working right, then I can get it working fast. Yeah, so let's see. Yes, so I should have a bounding box around this chessboard. And I don't. Yeah, and this isn't animated or anything, so this should be more simple. Also, my ducks are gone for my lights. Why? Yeah, that's what these boxes are here. The remember those ducks? I think, yeah, like one here, one here, one here or something. Why are those gone? Where are my ducks? Yeah, where are they? Like, I don't think I saw them here. Yeah, where did my ducks go? Confused. Model, light. You get model duck. You get light, add light duck model. And light, how are you going to debug without your rubber ducks? Yeah, exactly. Really, it's for the lights, and this just inherits from object. So, yeah, object instance IDs allocator, object calling data allocator. Yeah, these should be fine, and they should still like show up. I think maybe they're getting no, like everything in the visibility buffer should be 1. Let me go here. Or no, let me go here. Yeah. Just to ensure that everything is 1. I think I have like fill buffer somewhere. Yeah. So fill buffer. So let's see. Is this, where am I doing the draw calling? Right. So there's like reduce prefix somewhere. Yep. So call visibility buffer. Yeah. So run that. And then, yeah, so wait till that's done. But I'm actually just going to say fill this buffer with 1s. I think what's the prototype look like for this? Destination buffer, offset size, data. Okay, so data is the last one, actually. No, that should be 1. That should be 0. And then I want to fill the visibility buffer. And then I need some kind of shader storage, right? I know I have, what does the other one for fill buffer look like? Transfer right. Yeah, this is what I want. Yeah, transfer right, compute shader. Is that supposed to be compute shader? I don't know. Whatever. Oh, yeah, copy bit. Yeah, that's what I'm looking for. And then the destination is shader, compute shader, rewrite. Yep. So let's see. If I just force the buffer to be all 1s, right? So even like the weird instance indexing stuff won't cause a problem. Everything should be always 1s. Do I have my ducks now? Ah, crap. Invalid buffer object. Fill buffer, DST buffer. Yeah, this one actually ran the command. Visibility buffer. What? Does that make any sense? Did I name it? Is this like a typo? Because this should work. Visibility buffer. No. Invalid buffer object 00. Buffer must be a valid handle. Yeah, it should exist by the time this node. Maybe this is like, okay, yeah. This is that dynamic node crap I was talking about before. I hate it. Yeah, it works here because this has already been created, but it doesn't work here because this buffer hasn't been created yet, and it can get resized and all that. So this has to be a dynamic node, right? Because like when this actually gets called, it'll like pull whatever's in this buffer variable, and it'll never change it. Yeah, so this has to be a dynamic node. Just copy paste this. So this should be VK CMD fill buffer. And then, yeah, just delete all those. So then that's the command buffer. And then these arguments. Here we go. I think that should work. Okay, hey, there's the ducks. Yeah. So there's something wrong with the visibility buffer and the ducks. And also these are kind of, like I thought these were the ducks, but this is actually slightly wrong. Like these are offset, strangely. See that? Like the boxes aren't on top of these. So let me get the ducks working. Yeah, quack. Yeah, I mean, these are just, yeah, I don't know. I don't have a better model for doing lights, so they work well enough. So let me figure out how I cannot do this. How I can stop having to do that. So why would this not work? Because I'm creating the lights in the object manager, right? Like it's the same thing that I'm doing for the object. Like I'm just passing this stuff to the object constructor. Right light. Okay, maybe it's got, let's see, refresh instance data. Okay, maybe refresh culling data. No, I am refreshing culling data when I refresh instance data. I should be getting all this stuff because this is just in the constructor. And it should all get written right light. Yeah. And then refresh instance data. We should call this, which should queue this up. Oh, wait a second. Wait, yeah, it's not. Yeah, it's not refresh instance data. It's register invalid. Yeah. And then that tells this to actually run. Yeah, I think that's it. And don't you get registered invalid when you get created? Isn't that? Yeah, so that gets registered invalid when that gets created. So I don't have to worry about that. But then here, okay, but that's just the color. So I don't care about that either. But the position, yeah, when I change the position of the light, then I do want to register invalid. Okay. Bad interface. Yeah, so duck model. Yeah, so this is just adding lights with the duck model. Okay, yeah, and then here I'm like setting the position. Okay, yeah, setting the position of all of them, but I'm not changing the rotation or scale. Or no, I am changing the rotation. Okay, yeah, but then when I call that rotation Euler, that's actually this object one that it inherits. It's this, which runs rotation, which registers invalid. So that's good. Yeah, because like I have the light data and then I have the actual object data, and then I have to like overload position a little bit to get because I have the light position and the object position. Yes, and so actually, yeah, I'm running object position here, so I shouldn't even need to run this. Yeah. Right? Wait, so then why was this not running? Or is it running? Because, yeah, this should have ran anyway. Because this stuff does work. Maybe it was because I was manually running refresh and it was breaking things? It's weird. But, yeah, it should just be like this anyway. Because I'm using that position. Yeah. Okay, so, yeah, we still have the ducks, but then what if I remove that barrier? Or the, this thing here. Yeah. If I remove this. These are just objects. Like it shouldn't. Yeah, now they're gone. Oh, man. So why would they be getting cold? Um, so basically they're getting cold because, okay, yeah, because, so I have that set up, right? So let me just put this back to true so that there is no ambiguity about whether or not. Yeah. So these should be green, but they are red. And then I guess that's because the object instance IDs are wrong for the ducks. Yeah. So let me see what the yeah, when I add a light, yeah, light allocation, and then yeah, it should just create an object, which should run, should go through and do all this stuff. So like it shouldn't be any different than a regular object. Okay. So let's say let's go here. Let's say creating light I or whatever. Can't type. There we go. And then actually go on the object. And here I just want to know what its allocation is and all that. Yes. So objects allocation. So yeah, instance IDs allocation. This is the offsets. Remember how this works again. Right. So I have the visibility buffer. And then this here, this instance offsets, basically. This maps from the object ID to the instance IDs associated with that object. Okay. And these are global instance IDs. Okay. And so I guess I want to print out, right, and then there's this object calling data alloc. Right. And I'm going to end up doing offset here, but this is like when I actually call refresh. So yeah, object calling data alloc. Let me just say object calling data index is object calling data alloc offset divided by object calling data alloc. I think I just do size here because this should be, yeah, this is contiguous fixed allocator. It says it at the bottom. I don't know if you can read that, but yeah, the size is the same for all of these, so that's fine. Yeah, end line. So okay, that's a lot of stuff. Oh, right, because I put everything back. Well, anyway, yeah, creating light 0 is 7, 8, 9. But let me not make all of these. And probably just do it on like, I'll leave multi-threading on. That's probably fine. Run this again. Yeah, so creating light 0 is index 17, 18, 19. Yeah. So let's run render doc. Run this, launch. Yeah, ducks should be visible, but it's not. Let's see what those indices were. Yeah, so again, it's 17, 18, and 19. Makes sense. So yeah, creating light 0, object calling data. So I should be able to get everything from this. So object calling data, and this is number 17. And so Yeah, so this instance offset is at 180. Yeah. 180, 181, 182. Yes. And so now I can go into the instance IDs buffer and see, well, what's at 180, 181, and 182? 905, 907, 910. It's a little weird. Yeah, why are these... Okay, well, maybe that model has like 3 instances to it. That's... Or no, wait. No, I have 3 ducks, so I have 3 instances. How's this supposed to work again? Oh, man. Favorable. Yeah, 904, 905. Yeah, but then like, I would think this would just be like 906, 907, 908. Look at the visibility buffer. Right, so these are, yeah, this is like the very bottom. Okay, yeah, and so these are like nonsense. So what happens is I get to instances offset 180. Right, and instance count is 1, right? So only one I'm going to look at is 180, which is 905. So I should have a 1 at 905. I have 18 at 905. Why do I have 18 at 905? That doesn't make any sense. Unless if like the total instance count variable is wrong or something. Right? Because like I should definitely be writing to 905, 907, and 910. Right? Because that's, or yeah, 180, 181, 182. And so, yeah, there's extra fragmentation or whatever here. I guess I don't really care about that. Like, I want to eventually clean up the fragmentation, but for the moment, I'm not going to worry about that. Right? But I should be writing to these indices. To 905, 907, 910. Yeah, so that should be 1, that should be 1, and that should be 1. And it's suspicious these are like lower, but they're not actually 1. It's weird. And so my first guess is that it's because of this total object count is not right. Because maybe I'm just looking at the objects. Yeah. I'm just looking at the objects and not the lights. So that's what's going on. So total object count. Or no. Okay. Object manager. Add light. Yeah. So I see what's happening. So this total object count, where this is ultimately coming from, is this object manager. What is it? Object count, or where is it? Yeah, object count, which is just objects.size. And this is when I'm actually like creating an object itself, but then I also need to take into account the size of the lights. So all I need to do in total object count is object size plus light size. And now we should see the ducks. Hey, there we go. There's one duck. And then these show up as green, but I only see one duck. That's even more confusing. Okay. Well, that's an improvement. Yeah. So, yeah, like object calling data. Yeah, so 180, 181, 182. And I have one instance each. And then visibility buffer, or instance IDs. Yeah, so 905, 907, 910. And that's still, yeah, these are still 17, 18, 19. 905, 907, 910. These are all ones. Why am I not drawing the ducks? Because these should count as instances. Okay, I'm drawing the ducks here. but it looks like I'm only drawing, yeah, I'm only drawing one duck. Right, but then when I set visibility buffer to be all ones, I'm drawing multiple ducks. So there's some disconnect between the visibility buffer and the actual instance IDs. Oh, man. It's terrible. 905, 907, 910. Yeah. It's just weird seeing this stare at me. Anyway. Yeah. So that's that. Yeah, and this is just one instance. Yeah, so these ducks are just like a single primitive. So that's nice that these are simple. There's not like it's not like this engine where there's like multiple draw calls for it. There's just one draw call for all these ducks. So the instance count is wrong, right? But it's not a prefix sum problem because if I force it all to be ones, then everything shows up. So that's good, right? So the prefix sum code works. It's just the visibility buffer is wrong, right? And so the reason that would be wrong, so that would be if I look at the objects themselves, pull up indirect commands. So I know that these are object calling data index. Oh, that's not right. Well, I should be able to match some of these. Yeah. So if I look here, so this thing's first instance is 908, and I'm looking at the next three to figure that out, right? So I'm looking at 908, 909, and 910. Except in here, these aren't 908, 909, 910. These are 905, 907, 9. Or, yeah, 910. Yeah. So that's how I'm getting an instance count of 1 because only one of these is set to true. Here? Yes, that's the problem. So there's a disconnect between the object instance IDs and the actual like first instance plus instance count. Okay. And is that because I'm making multiple of the same model? Maybe. It might be because I'm making multiple of the same model without pre-allocating, so I run into running like fragmentation issues. So I think if I go and I pre-allocate, yeah, I don't want to do create n objects. Model pre-allocate. Yeah, I'm pretty sure it's just this model pre-allocate. So let me see if I say duck model pre-allocate bytes.size. Right, so that should pre-allocate me 3 ducks. And let's see if that works. Hey, there we go. I got all 3 ducks. Okay. So it is like a fragmentation problem. Yeah. I'm probably gonna have to think about this off stream because, like, ultimately, I probably just need to like defrag the buffers or something, and then like update all the offsets. But that's a lot, and I also don't want to like defrag like a whole buffer every time I add or remove something. So maybe that's a case for chunking the buffers to reduce defrag problems. Yeah. But so yeah, I'll stream for another 40 minutes and then I'll take like an hour break. And I'm just gonna leave a note in here. Or yeah, fix me actually. Model has to be pre-allocated, otherwise fragmentation issues cause the model to not get drawn to get cold. Yep. I can't. I don't know what it is. Like it used to work. You can't see, but like I can't click on my engine to get it to show up anymore in KDE. Where did this stupid? Yeah, this, I don't know what that is. KDE just being broken. Okay. Yeah. So I will fix that later. And then the other thing I want to try to get either, well, yeah, I want to get animations, and then I want to get like, there should be a box around here, and there's not one. Okay. I guess really all I need to add is, yeah, okay, I changed the light around a little bit, but no, no, yes, yes, no, no, I want to do separate commits. No, I should just get rid of that. No, okay. So this commit is for, yeah, clean up light or something. Clean up light, refresh. And then more stuff. Right. And so here, let's like get correct object count. Get correct object plus light count. And then let me clean up this. And then go in here, get rid of this. And I will leave this in because I'm going to try to figure out how other stuff works, why other stuff's broken. So, yeah. Let's see. No, 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 yes. Reallocate light / duck models to fix fragmentation issues. Okay, yeah, and then the rest of this is just temporary stuff. All right, go ahead and push that. Now, let me get rid of this. And this batch, I guess. These are just like to-do operations I have from the old one. But anyway, yeah. So fixing why these boxes aren't right. So that would mean. So so the problem is definitely that the bounding boxes are incorrect. Right, so everything else is working fine. It's just the bounding boxes are wrong for like specifically that chess model. So yeah, so it's this beautiful game. Right, and so I'm loading the model here. You know, to make this simple, I will just get rid of everything else except that. Yeah. Hopefully this doesn't break anything. Yeah, get rid of everything except that. Blue box. Yeah, because I'm unloading. That's fine. Yeah, because I'm unloading the model. Yep, okay. So this should just, things are broken. Update descriptor sets buffer is null handle. Why is the buffer null? Because I do have an object. Oh, right. The lights buffer is null. That's why. Um, yeah, I need to better handle null buffers. That's just, yeah. All right, I will have that and a few ducks. Okay, there we go. All right, and all these are broken anyway, so it's kind of good to put all these together, I guess. All right, so we've got 4 bounding boxes. So we've got this one, this one, this one, and then this one that's like inside the other one. And so this looks like the chess one, and it looks to be about the right size. It's just in the wrong spot. And it's the same thing with these duck models. They look to be about right, except they're in the wrong spot. So my guess is that has something to do with where is it? And it's actually easier if I show it in object first. So in object, so I have to calculate this position offset here using the bounding box. And so what this is so if I'm like importing models from a whole bunch of like random sources, they might not all be centered at 0, 0, 0, right? And then what this offset is basically calculating its distance from 0, 0, 0, and then I'm just subtracting it. So then when I actually set position, I can do like set position 0, 1, 0, something it'll put at 0, 1, 0 instead of like putting it way off to the side. And then I also have to take the scale into account, because if I scale down the base model itself, then like the model's position changes. And it's got nothing to do with like the ordering of my matrix multiplies. It's just like, or it's or no, like the amount I need to offset it by changes or something. It's weird and annoying. But yeah, I do have to do this. And so I think in the bounding box, I know I am taking these into account when I'm doing the bounding box, but maybe it's not quite right. Where am I even storing the bounding boxes? Yeah, so I think it's model. I don't remember where I'm storing these bounding boxes. Well, I'm uploading them somewhere, so that's a good place to start looking. Where am I uploading them? Right, like I know, yeah, okay, so here's like aabb.update, right? But then this just updates it for the model itself, right? Like I just have the base for the model, and then I actually modify it later on. Yeah. Yeah, update by animation matrix. Yeah. Where am I uploading this? It's not in draw. Nope. I would think it would be an object, but it's not. Right, I would think it would be like in here or something. Or okay, refresh culling data. Oh yeah, I'm blind. It's right here. Yeah. So I'm getting the model's bounding box, converting it to an oriented bounding box, and then again, converting that with rotation and scale, and then getting the position offset and just subtracting. Okay, but position. Okay, yeah, like position here. This is like the actual value I set. So I think, so this might be right, but then, yeah, the center point might change when I rotate and scale it. So that might be the problem here. Is I need to look at like the OBB center point instead of the that. Yeah, so I just need to figure out the right position offset for the OBB, and that should fix this problem. So, let me see how I'm converting these. Yeah, so OBB, so this is just like straight GPU data. And then here, yeah, so the center is that times the scale, the half extents. Yeah. Times the scale. So really, do I just not need to do the position offset? Maybe. It might be that this position offset is breaking it. I just remove it and see what happens. Yeah. Yeah. Because this center should be... I'm not sure. Let me just remove that and see what happens. Because I don't think it's actually centered at 0, 0, 0. But let's just see what that does. And like that's how I was doing it on the old code as well. Maybe the old code was broken too. Yeah, so see, it's still broken. Yeah, and now they're like, yeah, now they're like still kind of off. Okay. And it could also be them creating these oriented bounding boxes wrong. So yeah, I think position offset actually looks slightly better, but right. And so here I'm looking at the AABB center point. So what if I say data.obb dot center time scale? Let's just see what that does. Just kind of trying random things, seeing if it works. Because the math is kind of annoying to figure out. No, that looks exactly the same, basically. Okay. Yeah, so specifically for how am I modifying these? So the ducks. So the ducks, I'm actually not even changing the scale. I'm just setting the position for the ducks. Oh no, I am rotating. I'm rotating them 180 degrees. And then these chess pieces, I'm also rotating 180 degrees. So I wonder if I just don't rotate these, because it's like flipping them around because Vulkan has like negative Y stuff, whatever. If I don't flip those, then does this work? So like maybe I just need to flip the position. Ah, it's terrible. Yep, there we go. That works. Yes. So the problem is the rotation. Everything else is fine. Okay. And I think this actually should be OBB center times scale. Right? Yeah. Yeah. Like another way of thinking about this is this offset. This converts it from. This would convert the model coordinates, or this would convert the coordinates from like global space to model local space or something like that. Yeah, but now the OBB is not taking into account the rotation correctly, or at least its center point is not taking into account the rotation. Yes. I don't know. Yeah. So, except like I am doing direction UVW. I am doing all this, but is that for drawing it? Yeah, I am using this for drawing it. Is rotation times right vector, rotation times up vector. Get rid of the -1. Up vector is in negative y space, but rotation is in plus y. This converts direction v to plus y space, which is used for culling, I think. Ideally, rotation quaternion will be passed directly to frustum culling. Okay. I'm going to undo this -1 thing here, because maybe that's what's breaking things. Maybe not. Because now Now it might work now, but then, no, it's still broken. Right, am I flipping these? Yeah, I'm flipping these, so they're like right side up, because Vulkan uses -y, whatever. But it actually does look slightly better without that. Right, but then now, okay, what if I just get rid of that position offset now? Maybe this is the problem. Or, so I was just like overthinking it on the old engine or something. No, it's still broken. And now it almost looks bigger when I don't have the position also, which is kind of strange. Anyway. So... And also these should be like colliding with each other, I don't think. Well, yeah, like some of these bounding boxes, like the bounding boxes just seem a little too big. It's another problem. Right? But anyway, like I want to, like when I convert it to an OBB, and this is really more than OBB. Oh, you're back. Oh, I didn't know you were gone. Are your ducks quacking it? Yeah, so I don't know how much you missed, but like I got the ducks to show up. It was a problem. I had to like pre-allocate the model data because it was another like weird fragmentation issue. And so I just like pre-allocated the model data for it and then left it fix me. Yeah, but then what I'm trying to figure out right now is these bounding boxes are not in the right spot for some of these models, and they will be in the right spot if I don't rotate the models. So I go here, come at this, and then this might actually still be broken because I changed something else, but if I just don't rotate the models, then they should be somewhat better. Yeah, and then I think I put this back, and then I'm about to put one more thing back. Yeah, one more thing. Okay. I just have to flip them around. Yeah. Yeah, so there we go. So these are all in the right spot, but then when I actually rotate the model, the bounding boxes are in the wrong spot. Yeah, like the position is incorrect. So am I rotating? Okay, so I'm not moving the center. So maybe I just need to like move the center by the rotation or something. Times scale. Yeah. Maybe really I should just pass a whole TRS matrix into here. Right, yeah, because I'm updating. You have to update the position anyway, right? So maybe it's to OBB. I might just want to pass in translation, rotation, and scale. And then I can put in the right spot there. Yeah, so this is really just doing like more than just an OBB, but that's fine. Right? So I got translation, right? And pretty much I just want to take this bounding box and apply, so let's say fast TRS matrix, translation, rotation, scale, yeah, and then no, none of that's what I want to do. Like that. And do I actually already have this matrix and I can just pass it in? Fast T matrix. refresh culling data. Object matrix. Is this what I want? If R invalid. Fast T matrix. What? How does that work? Oh, right, because yeah. That actually makes sense. So, yep. So what this is doing is this is converting the position, like the position of all and all that of the model into a translation matrix, and then like rotation matrix and scale matrix. And these are just doing it. I have like custom things to do that because it's faster than how GLM can do it. Because here, like GLM wants to like create. If I try to do this with GLM, it has to like make a whole matrix and like multiply stuff together, and it's really slow. This is just like mem copy, and then like that's just multiply and mem copy. So, anyway, so then in this oriented bounding box, and it's more than oriented bounding box, but it's fine. Let's say map for const reference TRS, right? Then rotation, yeah, or I might still need to pass in the rotation separately. And the scale, I don't know. It's also not that good at math. But I mean, I figured all this out before. So, yeah, so the max, the min, right? So the max and the min there, and then I need to multiply by the scale. So if I just max min times 0.5, center half extents. Okay, yeah. That makes sense. And then, and these are vec3s, right? Yes. And so if I say like, is it, yeah, it's like TRS times OBB dot center, right? And yeah, it doesn't like that this is that. So I have to say GLM vec4, yeah, it's 1.0. And then OBB dot center equals this, and yeah, that should automatically get truncated down to vec3, but just to make it explicit, whatever, that's fine. And the same thing for half extents. This is OBB half extents. Okay, and then I need to rotate these directions. Yeah, but these are in like vector form. Yeah, because this actually orients it correctly. Right, an up vector. Yeah, up vector should already take care of the negative one. So why? Oh, right. Because I'm flipping it. Yeah. Yeah, really, I need to better handle the negative y. So Vulkan has like negative y coordinates instead of positive y coordinates. And I just need to handle that a little better. But for now, yeah, and I think, let me just do this first and see if this works. Even though ideally I wouldn't need to pass both the TRS matrix and the rotation in, but yeah, right. So this is move this vector by this matrix. Yeah. Make this the parent, make that the child, yeah. So that makes sense. Yes. And then to OBB should look like this now. And then an object, instead of rotation and scale, this should be object matrix and rotation. Yes. So let's see what that does. Okay, that looks sort of reasonable. Okay. It's still kind of broken. Yeah. Like, it's way too long, and then, like, this one is on the wrong side, and that one is just huge. Yeah, so, like, the half extents or something aren't correct, I think. Oh, right, and I'm still doing this stuff, so let me not do this. Yeah, let me not do that. Okay, that's slightly less terrible. Yeah, but then, like, this thing's bounding box is huge, and this one is small. Why? Like, these are oriented exactly the same direction. Maybe they're overlapping or something? I don't know. Yeah, they're probably overlapping. Okay. So this is still not quite right. XYZ, XYZ. Right, so like this just takes max and min. And then it does stuff with them. So maybe the better way of doing this is just say glm vec3 object max equals trs times max. I have to turn this into a vec4 1.0 glm vec4. And then object min is min. And then here, this max can use object max. And min can be object min. Right, and so that should correctly get the center point. Yeah, the max and min for the axle line bounding box. And then the oriented bounding box, the format I have it in is at center and half extents. And then I need the directions to actually orient it in. And that's where I'm getting the rotation from. Okay. So let's see what this looks like now. Hey, that looks reasonable. Sweet. And am I still flipping these? No, I'm not. Okay. Let me see what happens when I flip these. Now it's completely broken. Okay. All right. I just want to move the box by the matrix, by the object matrix. Yeah. So I think it's got something to do with like the scale and why this is broken. Object max, object min, max min. Yeah. So, okay. So this axis align bounding box. This is, this comes from the model. So this is just the bounding box for the model itself. And so I don't know if you were here when I explained it, but one thing I do have to do is offset the position when I'm actually setting the position of the model, I have to offset it by this here, because not all the models are centered at 0, 0, 0. And so, and like this basically just centers the model at 0, 0, 0. So that like if I say position 0, 5, 0 or whatever, right, at XYZ, then it actually puts it at like global XYZ instead of like local to the model or whatever, right? And so like this position offset just converts it from like global space to model space or something, or object space. I don't know, something like that. It works. Then I think part of this is one of the things that's getting confusing with these. Right. But basically, I just want to take I'm going to take the translation, the rotation, and the scale. Now, I wonder if I comment this line out, does this work now? Actually looks better. Sort of. Now they're like flipped on the Z or something. And they're also the wrong size. So that means like the max and the min aren't right. And I'm pretty sure when I convert it to vec4, I put 1 in here. Yeah, because that's like the homogeneous coordinate something something. Yeah. Yeah, and so I just want to take the I want to take the coordinates of the bounding box. That's like, this is just like just the model itself, and I want to basically just move and rotate the bounding box by the object matrix. That's all I'm trying to do here. Okay. Yeah, so I want to translate it by I'm going to take the bounding box, and I want to translate it by the so I do need to take offset into account, I think, right? Because if I have the if the bounding box is like way off, like 100, 0 or something stupid like that, yeah, it would be centered there, right? So then I need to recenter the box. So I do need to take into account that position offset. And what that position offset is whatever this right here. The center point times the scale, basically. Yeah, I subtract the center point of it times the scale, and the scale of the model itself, or the scale I give the model, changes where the bounding box's center point is. Does that make sense? I think so. Are you applying the rotation twice now if it's in the TRS matrix? Well, maybe, not sure. So like these directions. So these are for like the so an axis line bounding box. The basis vectors are just like x, y, and z. But in oriented bounding box, the basis vectors are whatever you give it. And so I'm just rotating at the x, y, and z by the rotation quaternion of the object, and that should give it the right orientation. I don't know how much that makes sense to you. Yeah, but then here I'm trying to change the center and the extents. Okay, but then yeah, I don't think I want to take rotation into account here because it is just here. Okay. So this was kind of right when I did it earlier. Basically how I did this before. Can I just... I changed a bunch of things. I kind of just want to reset this. So no, 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 yeah, I changed a whole bunch of stuff. Yeah, right, because the center and the half extents should still be at the x with the XYZ basis vectors. But because this is where I'm actually telling it what the real basis vectors are. So yeah, so then basically how I'm doing this, position offset. Right, so let's go back here. And let's say this is max plus min times 0.5. And this is max minus min times 0.5. Okay, and then the center and the half extents just need to get, I just need to subtract out the center point times the scale. And so rotation, and then I can pass scale in. So this is like what I was doing before. So rotation, GLM, vec3, scale. So this is just scale. And then this is vec3 offset. So then I take the center points and then I subtract position offset from it. Same thing here. Yes, so that's the center. And then let me actually just add rotation in here. Or translation. Or position, I guess. Position is better. Position offset plus position. Okay. Yeah, and those should be fine. And then I don't know what that should be, because stupid things with inverted Y. Yeah, it should be down here. 2 OBB. So position, rotation, scale, and then go into object. And then 2 OBB. Right. So this should just take position, rotation, scale. There we go. Let's see what this does. It's not right. Now, it could be something wrong with how I'm drawing the boxes as well. So X, Y, Z. So how does this work? Right. So I have, what is it? Yeah, I have these vertices, right? And so this is just like, yeah, so this is just like a box centered at 0 that goes like, that has like a length of 1. Yeah, so that makes sense, right? Because it goes from 0.5 to negative 0.5. So length is 1 on each edge of the box. Yeah, box lines. It should be like box edges, I think, but whatever. Yeah, so that makes sense. And then when I actually go in here, so I want to take, yes, so the XYZ of the position, and basically absolute value times the sign. Yeah, so I want to take the half extents of the box, of the bounding box. Yeah, which is like halfway in like one direction of it, right? Since the boxes, they're symmetrical on each side, right? So like the right side is as long as the left side in the case of X. So you just have the half extents, which is like that half. And then to that, I want to add the absolute value of the position and then multiply it by the sign of the position. Yeah, because I want to keep the sign But yeah, I want to keep the sign, but like if I'm doing it on the left side, then I don't want to just like subtract the half extents from the left side, which will make it smaller. I want it to be the absolute value times the position. So that makes sense. Or times the sign or whatever, yeah. So that all looks good. And then the vertex plus the center, yes, that makes sense. So just take that bounding box that's centered at 0, 0, 0 and move it by the center. And then now I've got this rotation matrix that I build up from the U, V, and W vectors. Mat3 rotation matrix. Yeah, okay. Why is this? Okay, because I have to multiply this by projection of U matrix, yeah. And then so I rotate this specific vertex by the rotation that I'm passing in here. So really, why am I not just passing in a quaternion? Because that's better anyway. Yeah. Why am I not passing in a quaternion? I don't know. I should be passing in a quaternion here. Okay. So let me change that around because that'll simplify things a good bit. Yeah, OBB. Yeah, so I should say like OBB dot rotation equals rotation, and then I can get rid of all this crap. And then half extents, yes, that needs padding, but then here, this is a GLM quad rotation, and that doesn't need padding. And then I can go in here, and this is there quad? No, it's vec4 rotation. And I think I just multiply it like this. If I remember how to do the quaternion, because it's in GLSL, so I don't know. Like, there's like two ways to format a quaternion. It's like if you put the W component on like the left side or the right side. I don't know if this will exactly work, but let's just try this out. But that should at least be simpler, because now I'm just directly passing the rotation. Right, and then so this is just the center. Yeah, so this is getting the center point here, which is just the max plus the min. Yeah, and the min can be negative. Yeah. So I'm getting, am I dividing that by 2? That's that times 0.5. I'm dividing by 2. Max plus min. Not quite sure. Maybe I don't need to divide by 2 there. Or maybe this is in... No, this wouldn't be an absolute value. That doesn't make any sense. Yeah, this is just new bounds. New bounds, yeah. I'm pretty sure that's... Like, this worked for everything else, so it's probably right. Yeah, position offset is center point times scale. I pass in scale. Position, rotation, yeah. Okay, let's see what this does. Oh, we crashed. Direction U, box dot vert. Oh, right, I forgot to get rid of this stuff. Rotation, undeclared identifier. OBB rotation. Wrong operand types for float and float, or there's no acceptable conversion. Yeah, but isn't it supposed to be like that? Or, I don't know. Let's just do that there. Is that how that works? Oh. Crap. Okay, there we go. Yeah, I almost crashed everything. Why did that crash though? Like I shouldn't have. Because I did change the definition of it. Yeah. Yeah, have the padding here. Right, because these have to be in groups of 4. Or like 16 byte chunks or whatever. And then quaternion is 4. Why did this... doesn't make any sense. Why did this get a GPU hang? Because a GPU hang is typically like I'm dereferencing a like I'm segfaulting or something. How did that cause me to segfault? Yeah. OBB rotation. Yeah, like it. That should be fine. Because these are I'm not sure why I got a GPU hang there. That doesn't make any sense. Because it should be aligned correctly. Yeah, it's got nothing to do with this. Like this is all I changed here. Center half extents rotation. Let me see. I think yeah, okay, I didn't merge it yet. Good. Because I think in the shaders here, I'm actually doing yeah. So in here I'm actually passing in translation rotation scale. Yeah, so Vec3 translation, Vec4 rotation, Vec3 scale. Okay. So at least with this isn't as simple as rotate vertex position. This is like some cross product stuff. Okay. Yeah, rotate a vertex by a quaternion. Okay, so it's not as simple as just a rotation times that. But still, that shouldn't have given me a GPU hang, even if I like rotated it wrong. Maybe something about like not a number or something. I don't really know. Right, like I'd expect like some garbage output, but not a GPU hang. Yeah, well, anyway, let me just say this right. Rotate vertex position. Position is OBB vertex. Rotation is OBB rotation. Yeah. Yeah. I expect to get a GPU hang again because I don't know why this worked. This shouldn't fix it. Okay, I just crashed. Rotate vertex position. Okay, this returns a Vec3. So this needs to be like a Vec4 1.0F or whatever. Yeah. Oh, yeah. Frozen again. Yeah, I don't know why. Doesn't make any sense to me. OBB. Oh, okay, but then, right, it's an object cold data. Right. Maybe need like extra padding after these or something. I can't. There is like scalar block layout. I should probably just be using that, and then I won't have any more weird alignment problems. But I'm pretty sure it's faster to not use that. I'm not quite sure. But yeah, I probably just need to switch to scalar block layout anyway. So I don't have to deal with stupid alignment problems anymore. Object call data. Pad 2, pad 3. No, that's fine. And OBB is just this. Yeah. So that all looks like it has the right alignment. So why did this work before? Because, I mean, I had a whole bunch of VEC3s, but yeah, like these are just 4. It shouldn't matter. I am recompiling, right? Yeah. Just recompile everything. And I'm probably gonna go get lunch soon. I don't know if you're still here. Yeah. I'm gonna get something to eat soon. Just see if this works after recompiling everything. Nope. We are very frozen. It is very frozen. Okay. Yeah, so still getting a GPU hang. Yeah, you're here. Yeah, okay. Okay, I want to get this working first and then go get some lunch, but I don't know why this is broken. Right, center half extents rotation. Oh, maybe it's right, so this is, what is this, 1624. Maybe it has to be like 32 byte aligned or something. But I thought it's supposed to be 4 byte aligned. What's the yeah, I'm not specifying the block layout. Let me see. GLSL memory alignment. Shader memory layout Vulkan docs. Okay. So extend alignment, base alignment. So extension allows the use of SVD 430. Array stride alignment for extended arrays. Base alignment is 4 bytes. Out only with standard layout enabled. Right, but this is a storage buffer, relaxed block layout. VEC3 is still defined in 16 byte alignment. Okay, yeah, if these have to be aligned to 16 bytes, then maybe that's the problem. Yeah, scalar block layout. I probably just need to use scalar block layout. But I don't know if there's any like drawbacks to using this. It only applies to scalar components of the block and its composite members. Only scalar components. Oh yeah, aligns values only to scalar components. Yeah. Extension now allows uniform blocks. Yeah, I just don't know if there's like any performance issues with this. I should probably just be using that. Here's some examples to understand the difference in alignment. Yeah, the GLSL docs are way better about this. This is like, Vulkan docs are just confusing me even more. Where's the GLSL spec? For the, not here. Some GLSL STD 140. Yeah, here we go. This is what I'm looking for. This is way more clear about how these work. Yeah, memory layout shared. Here we go. So alleviates a need, explicitly state the layout arrangement. Yeah, I know it states the layout arrangement. It's covered well here. Arrays of types are not tightly packed. An array of floats in such a block will not be equal to. The array stride between array elements is always rounded up to a VEC4. So arrays will only match their C++ definition of types multiple of 16 bytes. Yeah, make sure to pad if you're using VEC3. This layout works like STD 140, except with a few optimizations. Except for VEC3, which specifically, they're no longer rounded up to a multiple of 16 bytes. So a array float will match C array float. Note that this layout can only be used with shader storage blocks, not uniform blocks. Yeah, but okay, so I think, yeah, things have to be at 16 bytes. Then I'm pretty sure. Yeah. Yeah, because it's not 8 bytes, it's 16 bytes. But currently the OBB is aligned at 8 bytes. So I think I just need to say like GLM vec4 pad2. It's really stupid. But yeah, I might have to do it like this because now this is 4 bytes. This is 4 bytes. So it's 8 bytes. And then this is 12 bytes. And then this is 16 bytes. And these are 16 byte, or are these 4 byte aligned? Or, yeah, 16 byte aligned. Okay. So I think that's what I need. Oh. Let's see what this does. Hopefully I don't crash. And we crashed again. Okay, it still crashed, but I'm pretty sure this is right. And then I think I need to, right, or I don't know, or maybe now it's thinking this. I don't know how that's supposed to work. Because then I have this other struct here. Yeah, this is pad 2, pad 3. Maybe I just need to go to STD 430. Like maybe I can do this. Yeah, no longer rounded up to a multiple of 16 bytes. So yeah, I think I get rid of that. And then what is it? Here. Yeah. Then I can set object call data. Oh, wait. Yeah, that's why this is broken. I didn't change this here. Oh, right. And that's why I have the UVW vectors, because I need that for this. Right. Okay. Right. That all makes sense. Yeah, UVW wasn't for drawing it. UVW was for this. And yeah, I've been crashing here, not on drawing the boxes. I just completely forgot about frustum culling. I was just busy trying to get the boxes to work. Yeah, so this needs UV and W, I think. How do I actually get? Yeah, because like because these are these are the basis vectors multiplied the upright forward vectors multiplied by the rotation. That's what UVW is. Okay. Yeah, so I guess then how I was doing this before in the vertex shader was right. Yeah. Okay. So that was probably fine. Yeah, before I did rotation here. Yeah, and this probably still needs to be offset. But then I was offsetting it like earlier. I was doing the same thing, except I was offsetting it here instead of in the OBB. So like this is exactly what I had before, and it's still broken, which I guess makes sense. Yeah, I'm just gonna reset like all these changes, and then I'm gonna take a break for about an hour or so. Let me see if there's anything I want to commit. No, 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 no. Sure, I'll commit that. No, 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 no. Okay. Shem, remove, resolve comments. Okay. Well, yeah. And then I'm just going to do git reset card. Here we go. And then do this. Yeah. So, yeah, I need to look more in the math about bounding boxes again and figure out how this is supposed to work. Or really, yeah, I don't know if it's exactly the bounding boxes, but it's more about the like this crap with aligning it to the to like the position offset or something. I think that's really what the problem is. But anyway, like in any case, I've still got quite a lot done. It's like I need to fix. Yeah, and like this is just when they're rotated 180 degrees. Like that's it. Or maybe when they're rotated at all. Right? But I'm rotating these 180 degrees because Vulkan has negative Y. And so rotating it by 180 puts it into puts it like face up. Um, so like maybe I should just maybe instead of trying to deal with that, I can just like flip the view matrix and then everything is rotated, or like and then I don't have to worry about negative Y stuff anymore. Maybe I need to look more into that because it does get confusing trying to figure out all the negative Y stuff. Um, yeah. Yeah. So, yeah, that is getting cold. Yeah, like I see it disappear once that bounding box goes out of range. It's funny. Yeah, so I need to look into the math again about these bounding boxes. And then I'm going to take a break. I will be back in about an hour, or maybe later. I'm not quite sure. But anyway, I'll see you in about an hour.